Find the number of positive integer solutions of 3x plus 2y equal to 43. Positive integer solutions are being asked. Before we even begin with this, let's revise something quickly. This is the number line covering all the integers from minus infinity to plus infinity. Positive integers are from 1 to infinity and negative integers are from minus 1 to minus infinity. 0 is neutral. So non-negative integers will be those which are not negative from 0 to infinity, and non-positive integers will be from 0 to minus infinity. Now to find the positive integral solutions, we'll start with hit and trial, and then we'll formulate a method to save time. Start putting values straight away. You see such a question, start putting values. Put x equal to 1. Do we get an integral value of y? Yes, y is 20. Put x equal to 2, y will come out to be 37 upon 2. It is not an integer. Put x equal to 3, y will be 17. Put x equal to 4, y will be 31 upon 2, not an integer again. Put x equal to 5, y will be 14. Put x equal to 7, y will be 11. This will go on like this. Well, I know it's a long and boring process to check for every value, but now we have figured out a pattern. Value of x is increasing by 2 every time. Every successive value of x is 2 more than the previous value, and y is decreasing by 3 successively. So in x, the increment is of 2 and 2 is the coefficient of y in our equation. Similarly, the difference in values of y is of 3 and 3 is the coefficient of x in our original equation. So values of x are at a difference of coefficient of y and values of y are at a difference of coefficient of x. Now to count the positive solutions, limiting factor will be y. For x, the positive integral values will go on from 1, 3, 5, 7 up till infinity. But for y, we have decreasing values. So we'll worry about y only. Values of y less than or equal to 0 will have to be rejected. Look at the first value, 20, and divide it with the decrement that is occurring every time, which is of 3. 20 divided by 3 is 6 and remainder is 2. So 20 could be written as 3 into 6 plus 2. Next we have 17, which could be written as 3 into 5 plus 2. Then 14 is 3 into 4 plus 2. 11 is 3 into 3 plus 2. The pattern is quite evident, I guess. If we look at these values, the middle ones, we can get other values as well. 3 into 1 plus 2, which means y is equal to 5. We are not writing x values because x is increasing and will always be a positive integer. No conditions attached there. 3 into 0 plus 2, which means y is equal to 2. 3 into minus 1 plus 2, which means y is equal to minus 1. Which, by the way, we will not be taking as we are only looking for positive integer solutions. And y equal to minus 1 and all other lower values will not make it to the list. Again, look at this part. We have values from 3 into 0 to 3 into 6. From 0 to 6, these are 7 values. So we can say that there are 7 positive integer solutions or 7 ordered pair of x comma y which satisfy the condition given in the problem. Now while solving such questions, make sure that the coefficient of x and y are co-prime. Otherwise, you will be skipping some values in between. So this is important. Coefficient of x and y should be co-prime. In y is equal to mx plus c form, y is equal to minus 3 by 2x plus 43 by 2. And the graph of this linear equation will be a slant line with negative slope. On increasing x, y decreases. Now this part is important. This thing is important to note. Next question onwards, this will be the first thing that we'll be checking, whether the slope is increasing or decreasing. Let's take one more example. Alright, 16 and 42 are not co-prime. So we'll take the common part out and transpose it. Take out 2 common and divide by 2 on both the sides. This is 8x minus 21y is equal to 33. Now this is the equation we care about. I told you coefficients to be co-prime is important because otherwise you won't be covering all the solutions. Now in the previous example, we went by hit and trial to get the first set of solution, right? But this effort could also be reduced by this technique that I am going to tell you now. Step 1. Out of x and y, which variable has the smaller coefficient? Express that variable in terms of the other. Coefficient of x is 8 and y is 21. 8 is smaller, so we'll express x as 33 plus 21y upon 8. For integral values of x, 33 plus 21y should get completely divisible by 8. Now a little use of concepts of remainders from the number system. 33 divided by 8. 8 fours are 32, the remainder is 1. And 21y divided by 8, the remainder is 5y. So basically, for complete division, this 1 plus 5y should be completely divisible by 8. And for that, 1 plus 5y should be a multiple of 8. For y equal to 1, 1 plus 5y gives 6, which is not divisible by 8. For y equal to 2, 1 plus 5y will be 11, again not divisible. For y equal to 3, 1 plus 5y is equal to 16, which is divisible by 8. Put y equal to 3 in the original equation, x will come out to be 96 upon 8, that is 12. Now check for increasing or decreasing slope. Our equation can be written as 8x is equal to 21y plus 33. Increase x on the left hand side, y on the right hand side also increases. So if we have found one set of values which satisfy the equation, for all other values we know y increases as x increases. And as the coefficients of x and y are 8 and 21, x increases by 21, y increases by 8. So next value of x will be 12 plus 21, that is 33, and y will be 3 plus 8, that is 11. This way we can get as many solutions as we want. Next will be 54, 19, and to get the values before 12, 3, subtract 21 and 8 from 12, 3. That will be minus 9, minus 5. Now let's clear this space up. This list will continue on both the sides. So if no condition is given, like find the positive integral solutions or non-positive solutions, such conditions are not mentioned, then we can directly say that there are infinite set of integral solutions. Now what if I put a condition here? Find ordered pair of x, y such that y is between 0 and 200. Y is non-negative, so we'll start from here 12, 3 and onwards. Our condition is on y and y increases by 8 every time. So divide the y value by 8 and write them as 3 plus 8 into 0, 3 plus 8 into 1, 3 plus 8 into 2, and this will go on till 3 plus 8 into n. Now this 3 plus 8n is y, right? And y is less than 200. So we have to find the maximum value of n for which 3 plus 8n does not exceed 200. To find the maximum value of n allowed, let's first find out the value at which 3 plus 8n equals to 200. Equate it to 200, n will come out to be 197 by 8, that is 24 point something. Decimal part is not important. This is 24 point something, more than 24. Okay. Now only thing is important to understand here is that 24 point something, at 24 point something, 3 plus 8n becomes 200. So for n equal to 24, 3 plus 8n is going to be less than 200, right? Now for y equal to 3, we had value of n as 0. Then it was 1, then 2 and so on up till n equal to 24. So from 0 to n equal to 24, there are 25 integral solutions for x comma y. I hope this is clear. There is one more scenario that might occur when the coefficients are not coprime. Like in this example, calculate the integral solutions. 4 can be taken out common. We can take out 4 common and transpose it. X minus 2y will be 33 upon 4. 33 upon 4 is 8.25. Now we are asked to calculate integral solutions. X is an integer. Y is also an integer. X minus 2y should also be an integer only, right? But on the right hand side, we have 8.25, which is not an integer. So we can directly conclude that there is no solution. Questions based on integral solutions are not limited to linear equations. They can be asked in many other ways. Now I have made a separate video for that and you'll get to see it at the end of this chapter. Thank you for watching.